Local linearity. Okay. L'Hopital is coming in a second. Local linearity. Okay, a linear function. So if this makes a linear function at a certain point, what would be the approximate value? Okay, so if you use y equals mx plus b, okay, this is x and y. This is your slope. Okay, got it? So -3 equals -4 times 2 plus b. So -3 equals -8 plus b. So b equals 5. So y equals -4x plus 5. We good with that? So if you stick in 1.9 for that, so you take -4 times 1.9 plus 5. Well, -4 times 1.9 is -7.6 plus 5 is -2.6, which is the answer. Okay, local linearity. A local linear approximation for a function at x equals 1 is 2x plus 8. What's the value of f of 1 plus f prime of 1? Well, f of 1, you just stick the 1 in and you get y equals what? 10. Okay. What's the first derivative of this function? 2. So you take 10 plus 2 is 12. Okay? Problems like that, local linearity is super easy. Okay? It's just kind of basic algebra. You just have to know what slope is. Okay? This stands for slope. Slope is 2. All right. L'Hopital's rule, and this is always on the AP test. Okay, there's always a couple questions on L'Hopital's rule. L'Hopital's rule says that if we have a limit that's 0 over 0, that if we take the first derivative of the limit, then we can find an answer. Okay, first derivative on the top, first derivative on the bottom. Okay, so this one, whoops, what's the first derivative of the numerator? -2x. Because if we stick a 3 in, we get 0 over 0. Okay, we get 0 over 0. Did everybody trust me on that? Yeah. Okay, so the numerator is -2x. What's our denominator, the first derivative? The sine of pi over 2x, chain rule, times, oh, it's negative sign, thank you, times -pi over 2, chain rule, or pi over 2, because it's a chain rule, okay? So now if we stick in a 3 to this function, we get -6 over, what's the sine of 3 pi over, well, the negative sign of 3 pi over 2. So what's the sine of 3 pi over 2? -1 times a negative is a positive 1. So 1 times pi over 2 is that, right? So you get -12 over pi, and it is c. Okay, let's do this one. Okay, cosine of pi over 2 is 0. Pi over 2 minus pi over 2 is 0. You get 0 over 0. So you take the first derivative of both the top and bottom. First derivative of the top is sine of x. First derivative of the bottom is 1. So what's the sine of pi over 2?
1. -1. No, 1.
The sine of pi over 2 should be 1. Okay, e's. Let's try an e. If you put in a 1 here, you get e to the 1 minus e, which is 0. 1 squared minus 1 is 0. So take the first derivative. What's the first derivative of x e to the x?
X e to the x plus x e to the x.
X e to the x, you were close, plus e to the x. What's the first derivative? What?
No, you said x e to the
Plus x
plus e
e.
to the x.
Yeah.
That's what I said.
No, you said x e to the x plus x e to the x.
Okay, well that's what I meant because that's what I
Okay. So what's the first derivative of e? 0, because it's just like a number, 2.71616. 2.71 2.718281828459045. So the first quite a few digits of e. Okay. Denominator. You don't know that e?
That sounds like me when I was in 8th grade and memorized the digits of pi.
E equals 7. No. No. 2.718281828459045.
Yeah, like it's still going. Like what is?
But like, is this really necessary?
Yeah.
Well, this is Andrew Jackson and President Garfield written all over it. Andrew Jackson was what president of the United States? No, the 7th. Come on, man. He was the 7th president of the United States.
That makes more sense.
Courts failed you. Okay. And then how many terms did President Jackson serve?
18.
2 terms. He served 2 terms. When was he first elected as president of the United States?
1828.
What'd you say?
1828.
Good job. And then President Garfield.
The 45th president.
No.
The 4th.
No. President Garfield, he was a closet mathematician. He would do geometry proofs all the time. And so he even did a proof for a 45, 90, 45 triangle. There you go.
Well, why would you have to think about
Why would I have-
Garfield for that? You could just think of a triangle.
Well, no, but we're talking about presidents here. Come on.
That was no. I might remember that now.
Okay.
You guys get actually, let's not tell Ludeman. Okay, so we'll just write it out. Yeah, explain. We'll be impressed.
All right, so the denominator is 2x. If we put a 1 in, 1 times e to the x is, no, e to the 1, plus another e to the 1 over 2. So it's 2e over 2, which is e. Let's look at this one. If we put in a 0, we're going to get 0, 0. So what's the first derivative of the numerator? 4e to the 2x. Oh, times what? Nothing. It's not a
2x plus 1.
problems. There's no product rule or anything going on there. It's just simple power rule. All right.
E is to something other than just x. Isn't it a chain rule?
Yeah, it is. And we did it. That's why it's a 4. Okay. So e to the 0 is 1. 1 times 4 is 4. 2 times 0 is 0 over 1. So it's 4. Okay, let's do a natural log one. So we get 1 over 0 here, which doesn't work. So, well, what's the natural log of 1? It's 0. It's 0 over 0. That's why it doesn't work. All right, first derivative of this bad boy. Numerator.
1.
Okay, 1 ln of x plus
1 over
x over x, which is 1, right? That's why you were saying 1. Okay, good job. Over 2x. If we stick in the 1, the ln of 1 is 0. So you get 1/2. Now, the same happens for infinity over infinity. take the first derivative of the top and bottom, and you get the answer. Okay? So, what's the first derivative of the top here? Chain rule. 2 ln of 6x times the first derivative of the entire inside. What's the first derivative of the ln of 6x? 6 over 6x. Okay? Which is 1 over x. All over. Same thing on the bottom. 2 ln of 2x times 1 over x, because it's 2 over 2x. Right? I think that's right. All right. So if we put in, this isn't going to work out very well. Because what's 1 divided by infinity? Nope. Nope. Yep. So you get 0 over 0. So if it doesn't work out, we cancel. There we go. So then we still have infinity over infinity here, right? Because we have, then we do it again. Okay? What?
So the 2's cancel, then we're right back where we started.
2's cancel. But we're not right back where we started. Because we had powers on the outside. Okay? So the ln of 6x is 6 over 6x. And the ln of 2x is 2 over 2x. So both of them are 1 over x. So they're the same thing, which is 1. Wow, that one didn't go the way I was expecting it to. Okay, let's try this one. We get infinity over infinity if we plug it in right away. But now, if we take the first derivative, we get negative 9x squared plus 2 over 4, right? If you put in infinity on the top, you get infinity over 4, which is, you get negative 9 times infinity, which is negative infinity plus 2, which is still negative infinity. Divide that by 4, which is still negative infinity. Infinity times anything is infinity. Infinity divided by anything is infinity. Yeah, that's infinity as well. So there you go.
Awesome.
All right, last one. I guess this would make infinity over infinity, so we got to take the derivative of both. What's the numerator become?
1 over 3x.
No, it's 3 over 3x, which is 1 over x. What's the denominator become? 7e to the 7x. Well, if this is infinity at the start, what would the bottom be? Infinity. What would the top be? What's 1 divided by infinity? No! Yeah. What's 0 divided by infinity? Well, 0 divided by anything is 0.
If everyone's going to teach you a guy first try that.
All right, so there you go. That's local linearity and nope.